Hello and welcome. I am Mohan, your host and speaker for today's webinar. I work as an integration developer at Infometry. Thank you for taking the time to join us. In today's session, I will be discussing about data wrangling and transformation in Python. By the end, you will gain actionable insights to enhance your data processing skills in Python. Please feel free to ask your questions or share your experiences during this live session. We will try to address your queries, so let's get started. This session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bengaluru, India. We came into inception back in 2010, and since then we have been offering domain-specific analytics solutions for verticals like high tech, energy, life sciences, retail, manufacturing, and finance. Being a data analytics software services and solutions provider, we focus on delivering predictive analytics solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservice-based integration solutions, big data, cloud DevOps, Salesforce CRM, and product engineering. Infometry has been an engineering and consulting service partner for companies like Informatica, Matillion, Snowflake, Tableau, Adaptive Insights, Looker, etc. In addition to the services, we also developed more than 15 cloud connectors for IACS. One mentioned at the Blue Blocks are developed and owned by us, and the rest are developed by us for the organizations like Infometry, SAP Caldas, etc. We have developed state-of-the-art analytics solution, InfoFiscus, which can be hooked to any on-prem or cloud CRM, ERP, or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture, and it comes in three different flavors: finance, supply chain, and sales and marketing analytics. We are also delighted to announce the launch of the next generation InfoFiscal Sales Analytics solution, which is a Snowflake native application. It aims to streamline sales analytics for customers using Salesforce, Marketo, and Snowflake. So that's our quick introduction. Now let's move on to our today's agenda, which is data wrangling and transformation in Python. What is data wrangling? Data wrangling is the process of cleaning, organizing, and transforming raw data into more useful format. This involves dealing with inconsistencies, handling missing values, correcting data types, and more. So the goal is to prepare data for analysis or for further processing. And data transformation. Data transformation is a subset of data wrangling and refers specifically to the process of converting data from one format or structure into another. And this can involve operations like scaling, normalizing, encoding of categorical values, grouping, and aggregating the data. Why it is important? So, what are the benefits of data wrangling and transformation? Improved data quality. Data wrangling and transformation ensures that the data is accurate, consistent, and free of errors, which is critical for reliable analysis. Better decision making. Clean and well organized data leads to more accurate insights and better decision making. Increased efficiency. Automated data wrangling saves times and resources, allowing analysts and engineers to focus more on critical tasks. Data consistency. Data wrangling and transformation can help to maintain the data consistent across different data sets, which makes it easier to combine and also compare the data. Enhanced analytics. So a well-prepared data is more suitable for complex analysis or building data visualizations and even machine learning models. Now data wrangling in Python. So Python programming language is known for performing data analysis. It provides several built-in methods and functions for performing data transformations. These methods can be applied directly on data structures or collections like lists, sets, dictionaries, etc. Apart from this, there are three useful functions like map, filter, and reduce. So basically, map is used to apply a function or a transformation to each and every item of a collection. And filter, as the name implies, it is to filter out the items from a collection based on a condition. And reduce is to apply any rolling computation or an aggregation to pair of values in a collection. Now, along with these built-in methods, Python supports two powerful libraries for performing data manipulation. They are NumPy and Pandas. NumPy is a fundamental package for numerical computing in Python. It provides support for multi-dimensional it provides support for multi-dimensional arrays and matrices, along with a collection of mathematical functions that you can operate on these arrays. Next, you have Pandas. So Pandas is a data manipulation analysis library in Python. It offers data structures like series and data frames to efficiently handle and analyze the structured data. It has capabilities like data cleansing, transformation, grouping, aggregation, etc. Data extraction and loading. The data can be extracted from various sources or systems, including file systems. It can be a remote or local file systems. The data can be also extracted from cloud services like AWS S3, Azure Blob, Google Storage Bucket. And there are many Python libraries or packages which can be used to interact with databases or APIs. You can interact with the databases using database connectors or ORMs like SQL Alchemy. Request module can be used to call web services or APIs to fetch or load the data. So as mentioned earlier, Pandas library can be used to perform data wrangling and transformation tasks. We can load the files with various formats including CSV, Excel, JSON, XML, etc. It can also load the data from SQL database tables. And once the data is loaded, we will be using an object called data frame. So if you observe in the left side code, I have used an object called df. So this df is nothing but a data frame, which is a pandas data structure. We'll be using this data structure to perform data wrangling and transformation tasks. So once the required transformations are performed, we will be loading that particular data frame into any file. Data cleansing. The extracted raw data might contain missing values, duplicates, unnecessary fields or records. So it is important to cleanse the data. In, we'll be looking into multiple tasks in the data cleansing. The first task is handling of missing values or the missing data. Imagine that I'm having a data set where there is a column called price. I might be having a missing values for that particular column. Pandas provides two important methods, namely drop NA and fill NA. So this drop NA is easy to drop the record or row for which the price value or the value is null. So this drop in a method will remove that entire record for which the price column is null or missing. So it is not always recommended to use the drop in a because we might be losing an important information. Next we have fill NA. So this fill NA method is to fill that particular null value or the missing value with any value that you provide. You can even hard code the value, but here I'm replacing the null value with the mean or the average of the price column. Next you have subsetting fields. So basically in the subsetting of fields, you will only select few columns or the few fields from the data set. You can use a drop method, which is used to drop a particular column. So here, imagine that I'm having a data set with parking. I no longer wanted that parking column further, so I can drop that column. I can also subset only particular number of fields using this syntax. So here I'm only subsetting the price, area, and the furnishing status fields. In this way, I can only select only few columns. And next, filtering of records. So I don't want all the records to be processed. I only want the few records that satisfies a given condition. Just imagine that I'm having a area column and I want the records which are having area at least 10,000. So in this way, I can filter those records. I can even use the multiple filtering expressions. So I want the records which is having at least 3 bedrooms and 2 bathrooms. Don't worry about these columns. We'll be looking into the real world use case where we'll be understanding what these columns mean. The data transformation. So the cleansed data can be transformed to different format or structure to make it compatible across systems or datasets. So data transformation can help us to make the data more consistent and also well organized. The first task we'll be looking at data transformation is data type conversion. So we might be having a different data types for a column. So if you want to convert the data types, you can use a pandas method called as type. So when you load the data, there might be chance that that particular column might be of any another data type. So we want to convert that data type into maybe an integer, a float, or maybe another. So the bedrooms might be having a string data type initially. So I want to convert that into an integer. And the area might be having an integer. I want to convert into the float data types. So in this way, you can perform data type conversions. Next, applying functions. So imagine that I'm having a column called area. I want this is in a square feet. I want to convert this area from square feet to square yards. So I can basically divide each value by 9. I will be getting the corresponding square yard. So I'm actually using a pandas method called apply. This will apply each function. Here I'm using an anonymous function, which is a lambda function, and divide each and every value by 9. So in this way, you can apply any function to your column. Next, we have grouping of data. Just like a SQL, you can group and aggregate the data. So I'm having a furnishing status where I'll be having three labels, categorical values or discrete values like furnished, semi-furnished, or unfurnished. So I want to group the values or the other records based on the furnishing status. And I can also use any aggregate functions like sum, min, max, etc. Continuing of data transformation, we have concatenating the data. So basically, if you want to concatenate the data across the rows or columns, you can use the concat method. You want to concat across the rows, you can use this axis is equal to 0. If you want to concat across the columns, you can use the axis is equal to 1. Next, you have merging of data. Merging of data is similar to performing join operations. So, so now we'll be having two data frames here, df1 and df2, and I want to specify the condition on which I wanted to join the data. Basically, I'm using a column one here, and how do you want to basically merge or join the data? So I will use a method here called parameter called how here. Using this, you need to specify whether it is an inner join or left outer join or right outer join or full outer join. So basically, I'm using a inner join where I will be selecting the records that are common in both the sets or both the data frames. Next we have left outer join. I just need to use a left in the how parameter and it just need to pass the left in the how parameter, and we have a right outer join and we have full outer join. So this merging of data works similar to joins in the SQL. So in the inner join, you're gonna get the records that are present in both the data frame. I mean that left table or right table. Here I'm having the left data frame and the right data frame, which is df1 and df2. In the left outer join, you'll be getting all the records from df1 along with the matched records. In the right data frame, in the right join, you'll be having the common records from both the or matching records from the both the data frame along with all the records from the right, and the full order join will be having the records from both the data frames. So we'll be looking into the practical examples in the use case. Now coming to the case study, so imagine that I'm having a housing price data set, which is having a columns like price, area, bedrooms, bathrooms, and furnishing status, all of this. So I might be having many missing values here, like I have highlighted in the yellow boxes. And I might not be using all these columns, like I don't want this hot water conditioning, basement, guest room and all. There might be a particular columns where that I want to convert the data types into from integer to float or from a float to integer. And I want to group the data based on the funding status. So we'll be performing all these data wrangling and transformation tasks. So first task we'll be performing is the data extraction. So in the data, first I need to import the required library. So I'm importing the pandas library. I wanted to read the data which is present in the file called housing.csv. And once this data is loaded, we will have a data frame of df, which is an object. Now this object will be used to perform all the wrangling and transformation tasks. So I'm printing all the first five records using the df dot head. It will print the first five records. As you can see, the null values is represented by nan, which is of numpy type nan. So now we will be handling all these missing records. So in the data cleansing, we have a column called price. So I'm having some of the missing values for the price column. Now I want to fill that price column with average or mean of the column. So for this, I will use the fill NA method. Remember we discussed earlier that we can use drop NA, but with the drop NA, we're gonna lose the entire record. So it's not recommended. So we'll use fill NA. We will fill that missing value or replace that null value with a mean. So now if you see here, after we applied that data cleansing operation, which is a fill NA, now it has replaced that null value with a mean. Next we have subsetting or removing the fields. So I have a column called hot water heating. I don't want that column, so I can drop that particular column. This in place true indicates that operation is in place. If use it is a false, by default it will be false parameter. So another data frame will be a return. So it will not be performing any in place operation. So that's the reason I have used in place is equal to true. And since we are applying this across the column, so I need to specify axis is equal to 1. We will be having across the index as well. In that case, I will be using axis is equal to 0. So I'm printing the first two records. I'll be no longer having this hot water heating column here. And also can use the subset using this double square bracket. So where I will be only selecting these particular columns. Now here it will be returning the new data frame, and I can use this new data frame for the further analysis or transformation. So next we will be filtering the records. So basically I want only few records to be selected. So initially diff.shape is a parameter which will be returning the number of rows and columns. So first will be number of rows, and the second index will be number of columns. So I'm using the shape of 0, which will return the total number of records before filtering, which is 545. So we're having 545 records in total. Now I wanted to filter only few records. So here I'm using a condition where I want the records which is having the area greater than 10,000 and the bedrooms are at least 3. Now if you see the records at 13, so we have filtered out the records from original data frame. So now we will be processing only these 13 records. So now coming to the data transformation, will be converting the data types and also apply the functions. So if you see the data types initially for these particular columns, for area we're having integer, for bedrooms we are having the float. So now I wanted to convert these bedrooms into integer because bedrooms will be like 1, 2, 3, something like that, not like 1.2, 1.5 something. So I want to convert these bedrooms into an integer data type. And area might be uh, a float type. So that makes more sense, right? So we'll be converting the area into float. So if you see here, the syntax I'm using and the method is hash type. So I'll be converting the bedrooms into integer and I'll be converting the area into float. So if you see the observe the new data types, the area will be float and the bedrooms will be integer. And next I wanted to apply a function. So I'm having an area. I wanted to have the area in square yards. Maybe this area, the column they given is of maybe that it is in square feet. I want to convert into square yards. So I'll be applying a transformation, basically a function where I will dividing each value by 9, I will get the square yards. I'm also creating a new column to indicate that particular column area is in ads. So for that area of 16,200 square feet, so the ads will be 1800 square yards. So in this way, I have a new column added here. Next, continuing with the data transformation, we have grouping and aggregating. So I'm having a column called furnishing status. So there are totally three categorical or three discrete values, namely furnished, semi-furnished, and unfurnished. So I wanted to group the records based on this furnishing status, and I wanted to aggregate using the sum. So if you take here for the furnished, I'm having the total number of bedrooms are 60. If you take for the unfurnished, I'm having the total area is 29,144. So in this way, you can group the records based on a particular column and also apply an aggregate function. Additionally, you can also use your own aggregate or custom function. Here, basically, I'm using the max. So for furnished, I want the max of bedrooms, which is 4. And for semi-furnished, maybe I wanted to know the total maximum number of parking areas, which is 2. For unfurnished, I want the what is the maximum area that in ads I wanted to have. So it is 1800. So in this way, you can basically group and aggregate the values of the records in the data frame. Next, you have concatenation. So I'm using a sample data frames here, df1 and df2. Basically, these are the records, and column 1, column 2 are the column labels. These are the indexes. Now we are having these two data frames where we'll be concatenating across the rows and columns. So if you use the axis is equal to 0, which is across the rows, I will be concatenating this first data frame with the second data frame. So I will have that concatenated data frame. Now, if I want to concatenate across the columns, where the column 1, call 2, I wanted to append at the end of append the second data frame across the column, I can use the axis is equal to 1. So in this way, we'll be having the target or the resultant data frame. Next, we'll be looking on the merging. So as I mentioned earlier, merging is similar to joining operation. I'm having the two data frames here, left data frame, right data frame. Imagine that left data frame is the left table, df1 is the left table, df2 is the right table. I'll be using a column one. Based on this column, I will be merging or joining that. Initially, I'm using the inner method, so we'll only get the matched records. So in this two data frame, the matched records are C and D. So C and D of the column. So we'll be getting that in a resultant data frame. Now we want to use the left outer join, where I will be having the result as the matching records and along with the all the records from left data frame. So if you see the call to X, call to Y, call to X is nothing but the column 2 from the data frame 1, call to Y is nothing but the column 2 from the data frame 2. So for matching records, we'll be anyway having the values. For the unmatched records, column 2 don't have any values. So that's the reason we'll be having none, which is nothing, which is similar to null. Now we have the right data, right outer join, similar to the left outer join, but we'll be having all the records from right and along with the matched records from the both the data frames. And we'll be having full outer join here. I need to specify it outer. We'll be having the records from both the columns. So this is how I can perform the merging or join operations. And once the required data cleansing operations are performed and data transformation operations are performed, we wanted to load the data. So now I'm totally having 13 records, and I wanted to have the data frame, which is a DF object, to be converted into particular file. For that, I will be using two CSV, which will be basically taking all the records, which is a data set, and I will be loading that particular values to a CSV file, which is named as refined housing data.csv. So this is the target. So I'll be having the required columns and all the transformations. You can see the ads and you can see the resultant file, which is nothing but the refined housing data. So in this way, you can perform the data wrangling and transformations in pandas. Now, moving to best practices requirements. So initially, we need to understand the data requirements. We need to know the format, structure, and quality expectations. And also, we need to profile the data. We need to analyze the data for inconsistencies, missing values, and outliers before transforming. And we need also use vectorized operations like uh, using NumPy or Pandas so that you can process the records faster. And also we can use the data normalization. Basically, it is used to standardize the formats. If you have a columns like dates or currencies across different data sets, you can standardize them. And also minimize the data duplications. We might be having duplicate records, so we need to eliminate those duplicate records so that we can save or reduce the processing time. And there might be sensitive information while processing, so we need to ensure that we mask or encrypt that sensitive information. And next we have to follow the coding best practices. We can make the code more modular and also avoid the hard coding. So in this way, you can reuse the components and also following the proper naming conventions, which might be helpful for fellow developers. And incremental testing, of course, you need to validate the transformations at each and every step to catch the errors earlier. And you can also document each and every step, which will be helpful for others. So to recap, in this session, we have explored essential techniques for data wrangling and transformation in Python. It empowers you to clean, reshape, prepare your data effectively for the analysis. So we have leveraged the power of libraries like pandas to streamline your work data flow. So thank you all for joining this session. I'm open to questions. Please feel free to ask your questions. You can also push them through chat. We are happy to answer. Thank you.
If anyone have questions, you can post them or you can even ask, unmute yourself and ask.
Yeah, hi Mohan. This is Padma. So, what techniques do you recommend for efficiently managing and transforming messy real world data sets?
So for the real world data sets, mostly we will have two scenarios. One is handling missing values and another is handling outliers. So for the missing values, as I said earlier, you can use drop any to drop any null records, or and instead of using drop any, you can use fill any to impute some values or to replace the null values with any other values. And for handling the outliers, you can make use of a statistical methods like Z score or IQR, and you can even apply some transformations like any log transformations, so that the impact on outliers can be at least mitigated.
Okay. Okay. Thank you.
Hi, Mohan.
Yeah.
Yeah, thank you for the amazing webinar on data wrangling in Python. So I'd like to ask you, can you explain how to optimize performance when working with large data sets in Python?
Sure. So for the large data sets, there are various techniques various best practices that you can follow. One is to use efficient data types, because if you use efficient data types, the data processing can be much easier. In order to cleanse or in order to transform the data, it will be much easier. So you can make use of any categorical data types, like for repeated values. Assume that you have a gender. Okay, for the gender field, you will have a male, female, or other. So if imagine that there are millions of records. So instead of having that male, female, or others, you can encode them as 0, 1, 2, which will be so that only 0, 1, 2, which occupies very less space in the memory. So in this way, making use of efficient data types, also encoding of any categorical values, you can effectively handle large data sets. And next, for large data sets, you can make use of chunk processing, where you process the data in smaller chunks. So instead of loading the entire data set into a RAM or memory, you can make use of chunk processing. For that, in pandas, you can make use of chunk size while reading the file. And next, in the coding, you might be using loops, right? So instead of using loops, you can replace that loops with vectorized operations. For example, you can make use of NumPy or pandas. There are many methods. So all those methods perform vectorized operations. And next, I can think of is parallel processing. So in the parallel processing, for any CPU intensive task, you can make use of multi-threading or maybe multiprocessing. And apart from pandas, there is a library called DASK, DASK. So even you can make use of the task, so which will be helpful for processing the data parallelly. So it is most popular for the handling the large data sets. So in this way, you can efficiently handle any big data sets or real world data sets.
Yeah, thank you so much.
Yeah, hi Mohan. It's Vijay here. Yeah, Mohan, how do you approach data validation during the wrangling and transformation steps?
So to perform data validation, so the first step you can do is the schema validation. There is a library called pydantic in Python. Using that pydantic, you can define and enforce any data types or ranges or constraints to each of the column. We just need to declare the class, and the attributes will be the actual fields that you want to define. You can have any range or constraints to that. So that way you can ensure data consistency. So that's the one thing. And next you can have a range and value check. So you need to verify that numerical values fall within the expected range, right? And also whatever the categorical data is there, it must match the predefined category. And there in pandas, you can I mentioned earlier for the housing price data set, right? I used the filtering condition. So similarly, in the pandas, you can make use of conditional statements. You can flag that values or you can filter out any invalid data. So in that way, you can perform data validation. Next, of course, you can perform null and missing values like making use of a drop in a fill in a to handle any missing values. And apart from that, you can even perform cross-field validation. So there might be some dependencies within the fields in the same data frame. Like if you take start date, end date should come after the start date. So you can have this cross-field level validations within that same data frame. So in this way, you can efficiently perform data validation while transforming the data.
Okay, okay, Mohan, thank you.
Yeah. So, is there anyone who would like to ask questions to Mohan?
So, Mohan, can we use Python to completely not use ETL process?
We can use Python as an ETL process. Even there is a library called Apache Airflow, where you can, there is a library that you can implement data pipelines or ETL pipelines within the Python. So you can, yeah, of course, instead of using any third-party ETL tools, you can even make use of Python. For that, you need to use make use of Apache Airflow. And there are other techniques as well. Instead of using libraries, you can even implement the data pipelines without using any custom library.
Okay. Okay. Thank you.
Yeah. One last question I had, Mohan. So, how can you automate the data loading process, like after transformations, to support real time or like batch workflows, basically?
So if you wanted to automate the process of data loading, one thing you can do from a programming stand of view. So suppose the data is ready, it is transformed. You can make use of any libraries. Let's say you wanted to load the data to databases. You can make use of database connectors, even use SQL Alchemy, which is an ORM. So using this, you can load the data. Now, as I mentioned, as Padma asked, how can you automate, like how can you use ETL? The same way, in order to load, in order to automate the process, you can make use of Apache Airflow to build ETL pipeline. And next is once the data is ready, and you can maybe invoke any APIs that will load the data to target system. And you can make use of event streaming processes like you can use Apache Kafka, and you can set up triggers or event listeners in order to initiate the data loading to target system. So that's how you can do it.
Got it. Yeah. Thank you so much, Mohan, for this amazing webinar on data wrangling in Python and transformation. I hope everyone found this webinar valuable. And for the future webinars, I would request everyone to check our website and follow our social media profiles. Thank you so much. Have a nice day.